everyone, welcome back. And this week we're talking about covalent bonding and covalent compounds. So if you haven't set up your notes for this week's notes, this is what it looks like. You can pause the video and copy it into your notebook onto page 26. Make sure that you are careful about how you organize everything so you have enough room for the things we're going to be adding. All right, so these notes, as I said, are on covalent bonds, and by the end of this lesson, we want to be able to describe and draw covalent bonds. So our essential question is, how do we describe and draw covalent bonds? All right, so we're going to do a little compare and contrast here. We've already learned about ionic bonds, but we're just going to jot a few of the most important points down about those so that we can compare them to covalent bonds. All right, so remember, an ionic bond is between a metal and a nonmetal. It also has to do with electrons being transferred, right? One element, the metal element, loses electrons and the nonmetal gains it. And so the important part here is we are creating ions, right? So we're creating ions with an ionic bond. And then lastly, ionic compounds form crystals. So the chemical formula for what you see down here would be something like NaCl, sodium chloride. But because opposites attract, these sodium and chlorine ions, they form a big cluster and we call these crystals, right? So covalent bonds, on the other hand, form between two nonmetal elements. And these happen when electrons are shared instead of transferred. Okay, so keyword here is shared. Unpaired electrons from each of the elements are shared with each other. And that's how the bond forms, not from ions. All right, so covalent compounds are also called molecules. You've seen lots of pictures of these. In fact, there were lots of pictures of molecules on our Canvas page today. So here's our Canvas page, and I usually have like a decorative header here. This week our decorative header is a bunch of different kinds of molecules. And so notice these aren't forming crystals. They have a very specific shape. Just like this example down here, that's C2H4. It doesn't have a whole bunch, it doesn't form a crystal, it just has this molecule. All right, so next I'm going to show you how to draw a covalent compound. Right, the first step is the same as the step we learned for ionic compounds. The first step is to draw the dot diagram for each element in the compound. Okay, the only difference here is if we have more than two elements, one of those elements is probably going to be in the middle. And so we're going to want to put the element with the most single electrons in the middle. Okay. Next, we're going to pair up the single electrons. Okay, so you really only have to draw the part that's in orange here. Right, you can draw it all, you can write it all if you want to, but the orange is the important part. So pair up the single electrons from the middle and the outer elements by circling them. And I'm going to show you examples of what I mean. And lastly, redraw the molecule using a dash, or some people call it a stick, okay? And we're going to draw one of those dashes for each shared pair of electrons. So remember when we did ionic compounds last week, we redrew them with brackets, right? So we might have sodium here in a bracket, and we might have chlorine here in a bracket, and that was showing us that they were stuck together because they had opposite charges. Well, covalent compounds form molecules, and so we don't draw them that way with covalent compounds. I'll show you how to draw them correctly using these dashes instead. All right, so let's do some examples. You should have a spot to do 4 examples on your paper. And the first one we're going to do is CH4, okay, carbon tetrahydride. And so you guys can just write this compound name next to where it says example 1 in your notebook. And remember, the first step was to draw the dot diagrams. And so we have to remember how many dots are going to go around each. Well, here's our periodic table. We can see that we're dealing with carbon, which should have 4 dots because it's in group 4A, and hydrogen. Remember, even though hydrogen is over here, and we said that metals were on the left of this line, right? Hydrogen was the exception. Hydrogen is a non-metal, okay? So hydrogen is going to have 1 dot, carbon is going to get 4 dots. All right, so let's go back and do the dot diagrams because that's step number 1. And carbon has the most single dots. Okay, so I'm actually just going to put carbon in the middle because it can do the most sharing. And then I'm going to put hydrogen around it. All right, so now I have drawn the dot diagrams for all of my atoms in my compound, right? So this told me that I had 1 carbon, and this subscript told me that I had 4 atoms of hydrogen. So that is what I've drawn here. All right, the next step says to pair up the single electrons. And so I'm going to look for the single electrons, which they all are, right? So what's going to happen is hydrogen and carbon will share these 2. Hydrogen and carbon can share these 2. Okay, what you don't want to do is you don't want to try making these hydrogens share, okay? You're always going to share with the middle element here. Otherwise, they wouldn't become part of this whole compound, right? Okay, so now we can see each of these shared pairs becomes a bond. It becomes a place where the elements are stuck together. And lastly, we redraw the molecule using dashes or sticks instead of these circles. Okay, so now I have carbon, and this is going to look a lot neater now. Okay, there's my bonds between my carbon and hydrogen. All right, and so that's my last step. These are the 2 things you should have drawn. Oops, didn't mean to do that. Under example 1, you should have this part and then this final part. All right, let's do another example. This one only has 2 atoms, right? It says draw O2. And you might be thinking, well, how could this be a covalent compound? It's not a compound. And you're right, it's not a compound. It's actually an element, but we still have 2 atoms that are bonded together. We have an oxygen and a second oxygen because it says we have 2 of them. All right, and even though it's not a compound, it's a diatomic element, there is a covalent bond that is holding them together because they're both nonmetals. All right, so step 1 says draw the dot diagram for each of these elements. Let's find oxygen. Here it is. And oxygen should get 6 dots because it's in 6A. All right, so let's do, and also notice we're not going to have an element in the middle because we only have 2. That's just fine. All right, so you're only ever going to have something in the middle, you know, if you have more than 2. All right, now I've got my 6 electrons. Now it's time to pair them up. Well, how do we do that? Well, see, I have two single ones here and I have two single ones here. They have to bond somehow. So guess what? It shares more than one time. You can actually share more than once, right? And so this is like doing a one-handed handshake versus a two-handed handshake or a hug, right? So this is actually going to be a stronger bond than when two atoms only share one time, all right? And so we've paired them up already. We've done step number 2. And step number 3 is to redraw them. This time we draw them with the dashes. Now, we do a dash for each one of these shares. Okay, so this is going to be a double dash or 2 sticks. All right. The last thing is we still have to draw these other electrons. So I'm going to go and put these other pairs here. You'll understand why it's important to draw those when you get to chemistry, because when you get to chemistry, these are actually, you're going to learn that these play a big role in determining the actual shape of the molecule and making it bend and do all sorts of weird things. All right, so you should have this under example 2, along with that thing there, O2. All right, for example 3, we have another diatomic element. We have N2. Okay, so both of these nitrogen atoms are covalently bonded together because they're both nonmetals. So it's technically not a compound, it's technically an element, but it's still a covalent bond. All right, so let's take a look at the dot diagram. Where's nitrogen? Here it is. All right, that means it's going to have 5 valence electrons, so 5 dots. So let's go and put 5 dots on these. All right, so I've got my dot diagrams for both of my nitrogen atoms. And look at what we have here. We have 1, 2, 3 single electrons on both of them. So that means in order to get rid of all the single electrons, they have to share 3 times. Okay, so this kind of gets messy looking, but that's okay. That's why we redraw it, okay? And so we've paired up all the single electrons, and now we're going to change these circles to a dash or a line. Right, so much neater. All right, and then we're going to draw those other electrons that weren't being shared out here. And now this is my compound, right? This is my molecule. And I'm done. All right, so these are actually, I think, a little bit less work drawing molecules than it was to do the ions. All right, last one we're going to do, and look at this one. This one has 3 elements in it. They're all nonmetals. And so that means that it is going to be a molecule. And so let's go ahead and draw the dot diagrams. We already know that carbon has 4 because we did that earlier. All right, and we know that hydrogen only has 1. So I'm going to draw a hydrogen here, and I'm going to draw a hydrogen up here. And then oxygen we know has 6 because we used that a little bit earlier. So I'm going to go ahead and draw oxygen over here. And so notice I put carbon in the middle. I put carbon in the middle because carbon has 4 single electrons. That means it can share 4 times, right? All of these other ones have less than 4, so I put them on the outside of carbon, all right? So now I'm going to make all of the electrons paired up so that there's no single electrons anymore, okay? And so these ones will share once, and carbon can share with oxygen 2 times, and that way we get rid of all the single electrons. Now they're all sharing. Okay, now let's redraw this. Now we have, and it doesn't really matter how you set this up, as long as we show the sticks in the correct spot. We're on the last step here. And we're going to draw 2 of them between carbon and oxygen because they shared twice. And oxygen has some other electrons that were already paired up. All right, and so here's my molecule. And that is all there is to it. We're going to practice this some more during our synchronous meets this week. Okay, but there's the examples for your notebook. All right, the very last thing we're going to add is just something real quick about those single, double, and triple lines that we were drawing. We actually have a name for those. If we share one time, we have one pair of electrons, we just call it a single bond, okay? So you can just say one pair of shared electrons, or you could just say, right, one pair is the same thing as saying 2 electrons, however you want to say it. All right, a double bond is 2 pairs, right, that we draw with 2 sticks. So you could just draw these examples over here if you would like to. And a triple bond is 3 shared pairs, so 3 sticks like we drew with the nitrogen. All right, and that's it for this week. I hope that this is clear to you how we draw the molecules. If it's not, make sure that you come see me during office hours this week. Just send me a message and we'll do some extra practice. All right, I'll see you in class. Have a good week.